Today we will do electric field intensity due to a dipole for points on the equatorial lines. So as we have seen in this diagram, we have a dipole here consisted of two charges, minus q and plus q, separated by a small distance to a. O is the center of the dipole. Now what we are going to do today is to find the electric field intensity at point P because of which is at the distance r from the center of the dipole, O, because of this dipole which is consisted by minus q and plus q. So here, because we have two charges, minus q and plus q, the electric field intensity at point P will be due to which is minus q, and another one is because of plus q. So E minus q is the electric field at point P because of charge minus q, and E plus q is the electric field at point P because of the charge plus q. So the resultant electric field at point P, which is given by E, is equal to the after we have solved the electric field because of charge minus q, which is given by E minus q, and because of the charge plus q, which is given by E plus q. So let us start. Now consider an electric dipole consisting of two point charges, let us say minus q and plus q, separated by a small distance, let us say AB, which is equal to 2a here, by a small distance AB which is equal to 2a. Let us say our setting is in free space, okay. Now let us say let P be a point, on the equatorial line, okay, on the equatorial line of the dipole, at a distance r from the center of the dipole. Let us say that is OP, which will be equal to R. We have to find the electric field intensity let us say E at a point P. Okay, so at this point P here. So let us write about the two electric field. Let E minus Q, which is equal to PQ, which is equal to the field intensity, electric field intensity at P due to charge minus Q, okay, and E plus Q, which is equal to PR. PR is equal to field intensity electric field intensity at P due to plus charge plus Q, due to charge plus Q. Now since we have seen here, since we can write AP is equal to BP, here AP is equal to BP in this diagram. So the magnitude, we can write the magnitude of E minus Q and E plus Q are equal, so that is we can write here E minus Q, only magnitude, will be equal to E plus Q, magnitude of E plus Q. So now we can write E minus Q, which is equal to the magnitude of E plus Q, which is equal to 1 by 4 pi epsilon naught any charge, so Q divided by AP square, the distance AP square. So which is equal to 1 by 4 pi epsilon naught Q by 4 pi Q by, instead of AP square we can write it as R square plus A square. Okay, R square plus A square. We name this as equation 1. Here we can write, since AP square is equal to R square plus A square, because here we have seen that in this right angle triangle, in right angle AOP, right angle triangle AOP, so AP is the hypotenuse, so this, if AP square will be equal to the sum of this, the square of this hypotenuse, hypotenuse will be equal to the sum of the square of the other two sides. So AP square will be equal to AO square plus OP square. So AP square will be equal to A square, because AO is A square and OP is R. So A square plus R square, or we can write as R square plus A square, same thing. So now let us write about the angle also. So let angle PAB equal to angle PBA, let us say equal to theta. Now as we have seen here, if we look in this diagram, we have seen that the electric field E minus Q, here can be resolved into two components. One is along PS, another one is along PT. The one which is along PS will be E minus Q cos theta, and the one which is along PT will be E minus Q sin theta. So let us write about these two components. Now E minus Q has two rectangular components. Let us say E minus Q cos theta along along PS, which is parallel to BA. Okay, and E minus Q sin theta is along PT, which is perpendicular to BA. Then similarly, again we can write here, similarly for the electric field E plus Q here, the electric field E plus Q also can be resolved into two components. One is along PS another one is along PU. The one along PS is E plus Q cos theta, and the one along PU will be E plus Q sin theta. So again we can write here E plus Q also has two rectangular components. Okay, then let us write E plus Q cos theta along PS, which is parallel to BA, and E plus Q sin theta along PU, which is perpendicular to BA. Okay, now since we already know that since the magnitude of E minus Q will be equal to the magnitude of E plus Q, so as the result of that, what happened? These two components, E minus Q sin theta and E plus Q sin theta, because they are equal in magnitude but they are opposite in direction, so they will be cancel out each other. So we can write therefore E minus Q sin theta along E minus Q sin theta along PT, and E plus Q and E plus Q sin theta along PU will cancel out. Because they are equal in magnitude and opposite in direction. Now, hence let us try about the resultant electric field. So therefore we can write here the resultant electric field intensity at P is given by E, which is equal to minus E plus Q cos theta plus E minus Q cos theta. We will write also the electric dipole moment unit vector P here. Okay, now we will write something about this minus here. The negative sign indicates the direction of the resultant electric field intensity E is opposite to the direction of the electric dipole moment P. Okay, so this is the reason why we write minus sign here. If we look in this diagram also, we have seen that the resultant of the electric field at point P, that is E, it is along PS, while the direction of the electric dipole moment is from the negative charge to the positive charge, so it will be along AB. So if you look at the two directions here, one is along PS, another one is along AB, so they are opposite to each other. As a result of that, that's why we write the minus sign here. Now let us continue to calculate. Now we know that E minus Q cos theta and E plus Q cos theta are equal in magnitude, so we write it here, E. Now E will be equal to minus, instead of writing these two separately, we will add them to E plus Q cos theta, so, and the unit vector there. Since we can write here the reason, E plus Q magnitude is equal to E minus Q in magnitude. So the magnitude of E plus Q is equal to the magnitude of E minus Q. Now let us substitute the value of E plus Q from equation 1. So, or E will be equal to minus 2, instead of E plus Q, we will write 1 by 4 pi into 1 by 4 pi epsilon naught Q R square plus A square, okay, then cos theta and unit vector P. So, or we can write here E will be equal to minus 2Q by 4 pi epsilon naught, then R square plus A square. Now instead of writing cos theta here, we will write it as A by root over R square plus A square. Now we know that, for example, here, then we let us write first this one, P, unit vector P. Then here, if we look in this diagram here, so cos theta will be cos theta, it will be equal to the base which is A, by the hypotenuse is AP. But we know that AP square is equal to AR square plus A square, so AP will be equal to root over R square plus A square. So that's why this AP here is R square plus A square. That's why here root over R square plus A square. Okay, so cos theta will be equal to A by root over R square plus A square here. Now we will write it in short as the reason. Let us say here the reason is using equation 1, and here is, since we can write cos theta is equal to A by root over R square plus A square. This is the reason. So let us continue to solve it. Or E will be equal to, E vector will be equal to Q into 2A, we arrange it, divided by 4 pi epsilon naught. Here it will be R square plus A square, and here I can write R square plus A square to the power 1 by 2. Okay, so unit vector P. Now if we solve this one, we will get, or E will be equal to minus Q into 2A divided by 4 pi epsilon naught, then R square plus A square whole thing 3 by 2, and unit vector here is P. Okay, now we write it in terms of electric dipole moment, so let us write that side. Or here we can write E will be equal to minus P, now electric dipole moment P, by 4 pi epsilon naught r square plus a square to the power 3 by 2. Now name this as equation number 2. Okay, reason here is since electric dipole moment P is equal to Q into 2A with the unit vector P. This is the reason. Now at large distance, since the distance of the dipole will be very small, 2A is very small, so at large distance we can write that is R is much greater than A. So what happened? Then R square plus A square will be approximately equal to R square. So equation 2 becomes E is equal to minus P by 4 pi epsilon naught. Here this R square plus A square, it will be only R square now, so it will be R square to the power 3 by 2. So this square and this denominator 2 will be cancelled, so R to the power 3 will remain. R to the power 3. So it will be minus P, vector here minus P. Okay, so by 4 pi epsilon naught R to the power 3. Name this as equation number 3, and it is the required equation. So equation 3 is the required equation. Is the required equation. It gives the expression. It gives the expression for the electric field. Give the expression for the electric field intensity. For the electric field intensity due to a dipole okay, at a point on the equatorial lines. Okay, so with this we complete the topic today.